Hello, in this recording I'm going to present a project that I did for one of my master's classes called Data Exploitation Algorithms with C++, and basically it's a neural network optimization app. So basically you create a new neural network, let's call it MyNet. Number of inputs, let's start with 1 and 3 layers, for example. First layer linear, 2, and here you have the transformation functions, rational sigmoid, and 1 linear at the end. And if we do apply, the network appears, and you have with random parameters. And if you can change the value here, for example, and do run, and it changes the value, you can reset the parameters to get different values. Now we're gonna load data, a little data set that I prepared. And if we look at the data here, we have x1, x2, x3. I randomly generated 10,000 lines of x1, x2, x3, 3 random variables from, I think it's 0 to 10. And here you have x1 squared, square root of x1 squared plus x2 squared, and here you have log of x1 plus x2 plus x3, and the goal is to try to optimize the network so that it can predict the value within the range of the function based on the data. So here we do a new training. We're going to train x1, transform into x1 squared. Total count 10,000, in sample 5,000, out of sample 5,000. Learning rate, momentum rate, step, those are optimization parameters. I'm not going to get into that right now. Here you have play, and he does none. Randomize. Okay, so fix the little problem, and now we have the optimization here. So when we press play, we see that in sample roots mean squared error, and out of sample root mean squared error. And it decreases, decreases, decreases. Here we can plot trading. Okay, this is the error that decreases. We got to here, the optimization level. If we continue, and we can plot the error point by point on the 10,000 points. So we'll optimize, and after that we'll test. So let's say now the error is 0.2. Okay, if we change a little bit this parameter, does it improve? Oh, 0.19. So basically we're stuck right now. We're still decreasing, but very slowly. Okay, let's say show that solution here. So that's the solution. Let's say 2 squared is 4, 425. 3, 9, 4, 16, 5, 25. So he learned the x squared. So if we let him optimize more, he's gonna get to an even better solution, and it's gonna learn perfectly. And now with the other functions as well, with the other data set, we can test. You see, you can create a network of 2 inputs and transformation, or 3 inputs, and train that network. So that's the video presenting my neural network optimization software.